Metal binder jetting is a two-step process, consisting first in the shaping of a part, and afterward in the consolidation of that part. The shaping is made with a 3D printer, using metallic powder and binder. The consolidation is done with a sintering furnace. The shop printer is working with volumes up to 16 liters. The productivity rate can be up to 800 cubic centimeters per hour. Production files are computer-generated from a CAD file with a dedicated software. Parts are nested inside the production area, rescaled and then sliced. The use of binder jetting technology permits the stacking of the parts in the production.
The printing process starts with the build platform going down by one layer. After powder is spread with the roller going across the build platform, excess powder is then collected in a bin below the machine. Finally, the printing is performed during a selective deposition of ink droplets. The print head used is a single-pass print head with a 1200 dpi resolution. This process is then repeated until the build is complete. To keep the process under control, a recurring cleaning run is performed, consisting in purging and wiping the print head. A print test is also done before each production.
At the end of the print, a box will be retrieved, consisting of loose powder and inked parts. A curing will then be performed on that box, before extracting the parts from it. Curing increases the strength of the parts inside the box. For that, the box is put inside an oven, and its contents are heated up to 165 degrees. Powder collected from the bin of the printer is also receiving this treatment to ensure a clean powder afterward.
Depowdering is the last step before the sintering cycle. The parts are currently in a green state. They are called green parts, and they have low mechanical properties because they are made of metal powder and solidified binder. Hence, the box will be carefully depowdered inside a closed cabinet using brushes and compressed air. The extracted parts are then cleaned and stored, waiting for their sintering. The shaping step is now finished.
Metal binder jetting technology makes possible the recycling of powder. For that reason, all loose powder in the depowdering cabinet is collected and automatically sieved. For the powder to be used again, a percentage of new fresh powder will be added to the current powder lot. Homogenization will be achieved with a blender.
Sintering is a thermal treatment for bonding particles by heating the green part just before its melting point. During the sintering, the parts sometimes need a little help, and they are usually placed on top of a setter to prevent the distortion during the densification of the part. The debinding step is included in the profile just before the sintering, and this is a necessary step to obtain a 100% metallic part.
Parts are placed on a multi-level graphite trays surrounded by the heaters. A vacuum pump will remove the oxygen in the chamber before replacing it with sintering gas. The furnace will first reach the debinding temperature and then rise up again to its sintering temperature. The sintering usually lasts 1 or 2 days in total, including the cooling. Once the cycle is finished, the furnace is opened and the parts can be retrieved. The consolidation step is now complete. When the parts are densifying, a 20% shrinkage occurs. At this stage, the parts can be heat-treated and surface finished.
Metal binder jetting is a technology that provides many benefits for making highly complex end-use parts with high productivity. A well-controlled process all along the steps shown previously is the key to achieve a good part quality.